Hello, in this video we are going to see some basics of the circular patch antenna, how we can design a circular patch antenna, that is what are the basic design equations for a circular patch antenna, some of the basics and what are the main importance of the circular patch antenna over the rectangular patch antenna and what are the some of the applications. So let's see that. So when you consider a circular patch antenna, the radiating sorry the radiating geometry is circle, and the main parameter that we have to consider while designing the patch antenna is this radius A. As we have a circular geometry, the electric field distribution inside happening on this circular patch antenna is Bessel function. So this Bessel function is actually class of special functions that commonly appear when we have a wave motion which is in circular or cylindrical symmetry. So I will tell that using some analogy. So this is one of the analogy. So if you drop a stone in the water, here, if we are putting a stone here, we can see the ripples move outwards in concentric circles like this, right? And here you can see how the ripples are varying from the center to the edges. So the height of these ripples as they move from the center to the edges is described by the function Bessel function. So similar distribution is happening inside the circular patch antenna also. So this is the electric field distribution, and this distribution is similar to this distribution, that is the Bessel function. As the electric field distribution is having the Bessel function distribution, the design equation consists of lots of mathematical equations, but I'm not going into much details in the mathematical derivations. I'll be just putting out the fundamental equations. So when you consider the patch antenna, the dominant mode of the radiation in circular patch is TM11. This means that transverse magnetic mode. 1 means as it is a circular patch, we have to consider a circular axis which having the axis rho, phi and z, and this means that it will be having the magnetic field along rho and phi axis. So the resonant frequency for this circular patch depends upon the effective radius of the patch antenna, because the effective radius is happening because of the fringing. So when you consider the electric field inside a patch antenna, so this is a cross section of this area. So I have taken the cross section of this area. Here you can see that the electric field is going out from the patches to the air and then to the dielectric. So at both ends the fringing is happening. So it has an effective area which is more than the physical area A. So the resonant frequency actually depends upon this parameter 1.8412 into C by 2 pi AE, where A is the effective radius and square root of epsilon r. And this parameter 1.8412, this parameter depends upon the Bessel function. So it is the first zero of the Bessel derivative. That is this value. Okay. So let's go into the design equation. So when we are considering a circular patch antenna, one of the main step is we have to calculate the parameter f. So here this f we usually say it as the pre-calculation factor or the nominal radius. So this actually represents the radius without considering the fringing field. So this is the first factor that we have to calculate. So this actually gives an indication about the area when there is no fringing field. So this is the first step. So calculate the nominal radius or the pre-calculation factor using this equation. Then use that value and substitute in this equation to calculate the physical area A. So here you can see that f is substituted from here, and H has to be specified in centimeter and the resonant frequency has to be specified in the unit hertz. And this parameter actually represents the fringing, and this is derived considering the fringing capacitance. So this is how the radius is calculated. And if you have to design a circular patch antenna with inset feed or the probe fed, so this may be the point where the impedance is matched to the 50 ohm. So this is the input impedance, and it is given by the expression Rin of A, J1 square K of R by J1 square of K of A. So where J1 actually represents the Bessel's function of first order. So instead of going into the rigorous mathematical calculation, one of the simple things that you can do is this feed point is actually about 30 to 50 percentage of radius from the center point. So if you calculate the radius and just take the 50 percentage or 30 percentage of A and just put the probe at this point, it may be the 50 ohm impedance match. At this ends, the impedance will be very high. Here the impedance will be around 200 in 400 range, and at the center the impedance will be in the 0 range. So the impedance is increasing from the midpoint to the edge. So this will be the point where the impedance is matched to the 50 ohm. And next is the effective radius. As we have seen earlier that because of the fringing, there may be because of the fringing, there may be reasons like 1 minute. So, okay, because of the fringing, the electric field will be leaking into the air and going into the dielectric and then to the ground. So the effective radius can be given by this expression, which depends upon the physical radius A. And when you consider the radiation, it is occurring because of the fringing at the both the ends, and because of these fringing fields, the fields will be uh, coming out of these circular patches and it will be having a broadside pattern. That means that the field is perpendicular to the axis of the antenna. So when you consider rectangular patch antenna, circular patch antennas are compact because they will be occupying less area as compared to the rectangular patch antenna. And as this circular patch antenna are symmetric, which can be mainly used for conformal and variable antenna applications. And some of the feeding techniques that we can use for the circular antenna case is coaxial probe, microstrip line, or aperture coupling. The main applications are GPS, RFID, satellite uplinks, biomedical implants, and wearable. So I hope you get some idea about what is meant by circular patch antenna. Thank you.